Okay, in this lesson we're going to work with graphs of sine and cosine functions. Before we start, we're going to recall some of our properties of sine of x and cosine of x. So the first thing we're going to talk about is remember our domain, and our domain we said was negative infinity to positive infinity. The range is going to be, let me change that to a bracket, so it's from -1 to +1. Let's split these. It's considered continuous and smooth. Sine is an odd function, and we talked about odd properties in the last lesson. It's an odd function. It has a period of 2 pi. And we also remember that this one goes through the origin, the parent graph. The origin meaning the 0, 0. Okay, let's come over here and also talk about cosine of x. And we'll remember some of those properties. So the domain of cosine of x was what? Negative infinity to positive infinity. Good. The range is the same. Smooth and continuous. Okay, this is the main difference, is this one's an even property. And so we talked about the even properties in the last lesson. We also has a period of 2 pi. And this one goes through the order pair 0, 1. So the main difference is, if we compared these two, they're very similar in a lot of ways, but sine of x is an odd property, even is cosine. Cosine is an even. And the other difference is the sine goes through the origin and the cosine goes through 0, 1. Okay, so I've already provided you with an image of this y equals sine of x, and we kind of looked at it on the applet, but let's see exactly where this comes from. So we're going to take just a few minutes to jot down an xy table, and so I'm going to pause the video and set that up so you can do the same. Okay, we're going to just specifically use these. Once we do this many, 1, 2, 3, 4, it looks like 5 points, you'll have the idea of how this thing comes to this form up here. So first of all, we have a given function y equals sine of x, and if we pick particular x values, so let's do sine of 0. So our first one, we will have y equals sine of 0. Now remember, by definition, sine is equal to the what value? Sine is the y value, right? Good. So when I go to over here, go to 0 degrees, what's the sine value? 0. Good. So when x is 0, y is 0. Now how do I write that as an ordered pair? 0, 0, right? So I just put those together and I get 0, 0. Good. Let's move to our next point. So if I plugged in y equals sine, this time I'll let my x value be pi halves. That's the one we're working with. Let's go over to our unit circle. Pi halves is here. What is the y value? 1. Very good. So 1. So what would my ordered pair be? Pi halves, comma 1. Okay, and we're just going to proceed through this. We're going to do our next point, y equals the sine of pi. We come find pi on our unit circle, and that's this. What's the y value at pi? 0. Good job. So then now our ordered pair is just going to be x value, comma y value. 2 more. Y equals the sine of 3 pi over 2. We have our unit circle pulled up, so here's our 3 pi over 2. What's our y value? Absolutely, -1. Good job. So we have 3 pi over 2 comma 1, and our last one is 2 pi So y equals sine of 2 pi. 2 pi puts us back over here, right back where we started. And that value is going to be 0. So 2 pi comma 0. Now we're left with ordered pairs, 5 of them in particular. I'm going to change this to blue just because. So 0, 0. Okay, now let's go up onto our graph and plot these. So if I had this graph from 0 to 2 pi and its increments pi halves plus pi halves plus pi halves plus pi halves, even increments, then I plot the ordered pairs. So we have 0, 0. Our next one was pi halves comma 1. So we go over pi halves up 1. That's this ordered pair. Our third one is go right pi units up 0. XY value there. 3 pi halves negative 1 and pi over 2 comma 0, and then we would just sketch that graph. So we didn't do all of these points in between, but it's pretty obvious how we get to that, and I just wanted you to see the whole process taken out to see how you use the unit circle to fill these out. Now this is a particular parent graph of our sine function. We're going to be talking about different types of sine functions when it's not just the parent graph, when we have different amplitudes or different periods going on. But this is the heart of how we derive this sine of x function to see all the components of it. Okay, before we move on, I want to take a minute just to reiterate and express to you what it means when it's an odd function. Odd means it's symmetric about the origin, meaning if I folded my paper here and I folded my paper here like almost 4 times, visually some of you can grasp this, these 2 points would land on each other, but odd meaning exactly opposite. So for example, I can see the point pi halves 1 is here, the exact opposite, negative pi halves negative 1 is going to be the other point. That's what symmetric about the origin means. So it's easier to see it if I gave you specific points. So we'll also show you about even as well. Alright, next we're going to look at y equals the cosine of x. We're going to do a similar thing, so I'm going to take a few minutes and set up an xy table down here and get everything ready for us to evaluate. Okay, I think we started with these 5 points over there. We're going to do the same thing. This time, cosine of x. By definition, the cosine of x is equal to what value? The x value. Good. So when we go to our unit circle, when our x value is 0, when we go to 0 in the unit circle, what's the x value? 1. Good. So the now we will get the ordered pair 0, 1. That's by filling in y equals the cosine when we let x be cosine of 0. That's what we evaluated on that last one. So we went to the cosine of 0 was 1. That's where we put our answer in. Now let's do pi halves. So we'll do y equals the cosine of pi halves. We now go to our unit circle to evaluate this. So go to pi halves. What's the cosine value, which is your x value at pi halves? 0. So I plug that in here and then I make that into an ordered pair, pi halves comma 0. Alright, let's do y equals to the cosine of pi. We move to our unit circle, we find pi, and we choose the cosine value, which is our negative 1. And we write this as an ordered pair, x comma y. Y equals cosine of 3 pi over 2. Move to your unit circle to 3 pi over 2. The cosine value is 0. So it's 3 pi over 2 comma 0. And our last one is when we evaluate the cosine of 2 pi. Which 2 pi puts us back over here at 0. And the cosine at that value is just going to be 1. So the order pair 2 pi comma 1. And the last thing we're going to do is we're going to come up here on our graph and actually just plot these points out. So 0, 1, which we knew that from our properties that it goes through 0, 1. Pi halves 0. Pi Negative 1's the third point. 3 pi over 2 comma 0 and 2 pi comma 1. So we only evaluated 5 of these points, but that's more than enough for you to see how that works.